Okay, now let's try to understand a few very common pointer mistakes that students make, or in general, I've personally made writing C code. Right? Again, this is not an important video, so if you feel like you don't really want to go into a depth, that's totally fine. But if you're somebody who's writing programs in C, or somebody who's studying in university and data structures are covered using the C language, I think this would be important part to understand, right? Okay, so let's try to understand the few common mistakes. The first one is dereferencing uninitialized pointers. Right, so over here, if you notice, I created a pointer and then I'm trying to set this pointer as the value 10. But remember, this is not exactly what we can do, right? I have not created a value a equal 10. I have not reserved value for this 10 already, right? I just declared a pointer and then I'm trying to dereference this pointer and set the value 10 over there. But remember, I need to actually have some memory to store the value 10 as well, right? So first common mistake, make sure that you don't make it. Second one is dangling pointers, right? So this concept basically means that you declare memory for a pointer and then you free it and then you try to access that memory again. So let's take a look at this example, right? I declare this pointer and dynamically allocate memory for an integer. So what's going to happen is I create this pointer, right? I create this memory is going to get created of 4 bytes, and I would um, let's say the address is 0x6000 once again, right? So this P would be this address, right? And it would get created. So this much space would get created, right? It would be equal to 4 bytes, right? But when I free this memory, right? Freeing basically means I explained it in my first lecture. When we dynamically allocate memory, it is stored inside the heap, but we need to make sure that we free the memory before we exit the program, right? So in this case, when we free it, this memory would get removed, right? This reserved memory for our program would get removed from the heap. But when I try to set this value now, right, since no longer it exists inside the heap, this would give me an error. This particular line would give an error, right? Okay. Third one is the memory leaks that we can have. So if you just declare dynamically allocate memory, just like I said, in heaps, we need to, they don't automatically take care of the memory we create. We need to make sure that we free it before we enter program, right? Otherwise, it can cause memory leaks. Memory leaks meaning that that memory stays somewhere in our system and we can no longer access it, right? Okay. Third one is the pointer type mismatch, right? So just like I said, in order for a particular data type, we need to declare the pointer for it as well. So if I need to point to a character, right? I need to create a pointer to a character. Why? Because different types of data types require different amounts of memory, right? So a char requires 1 byte in usual, integers usually require 4 bytes. So we need to make sure that we don't make that mistake. So if you look at this code snippet, right? I declare a value int equal a equal 10, but then I create a char pointer and then set it as the address of a. This would be incorrect, right? But because this is a char pointer, it should point to a char, and char meaning that something that requires only 1 byte, right? Or the space that a char needs. Last one is the out of bounds access error. So remember, if you look at this code snippet, right, we need to make sure that we stay within the bounds of whatever array or whatever we have created, right? In this example, I create an array of 3 integers, right? So something like this, right? I set the pointer to the ARR. So let's say if this is, let's say the first address is 0x7000, right? Let's say that's the first address. What's going to happen is ARR would actually be the 0x7000, right? And I would set P. So P would actually store the address over here, right? Something like this. So P equal 0x7000. But if you look at this code over here, right, what I'm trying to do is I'm doing P plus 5 and trying to set it to 10. But remember, the array I created was for 3 integers, right? Meaning in memory, 12 bytes have been reserved for me. So in total, 3 multiplied by 4 bytes for each integer would result in 12 bytes. But when I do this, right, this is like p plus 5. So it's going to try to go out of bounds, right? This will go out of bounds, and I'm trying to set the value 10. This would be invalid, right? I'm going beyond the point, beyond the memory that I've reserved, and trying to set it to 10. So it would be incorrect once again, right? So I hope you were able to understand this concept as well. And that was pretty much it. I've covered pointers in entire detail. And next we will move on to other concepts.